Hello Stats class, here's the chart for chapter 13. Yes, 13.1 has a chart, and 13.2 is not on a quiz, so we don't have to worry about that. So Anova stands for Analysis of Variance. I hope you knew that before I said it. And it is for comparing means of multiple populations by analyzing the good variation, which is between groups, and bad variation, which is within groups. And the null hypothesis for this, we basically learned one significance test in this lesson, so that's kind of nice. The null hypothesis is mu1 equals mu2 equals mu3 equals however many you need all the way up to k, which is how many groups there are. You do as many of these as you need. And the alternate is that at least one of these population means is different. So easy hypotheses for this unit. Don't forget, though, to add the context, which is where you define what the different means stand for. Mean of what, and which population is which. Define your parameters. Alright, conditions. There are 4 of them in this unit, and they are random. I'll write the words first, then I'll come back to the details. Normal, independent, and equal variance. So how do you check those? There's lots of room to write that on this chart. So the random thing has to be random samples from each population, or you might have randomly assigned treatments, and that would be given in the problem. Normal would be either the sample sizes are large, all n's would have to be bigger than 30, or the graphs that you would look at are not too skewed. It's pretty rare for them to tell you that the populations are normal, so we're going to check the graphs. Independent, same as we've done before, all the n's, all the sample sizes for all the samples have to be less than 10% of their population. Or if you have randomly assigned treatments, then that would cover that. And equal variances, you can either look at the graphs and see if they are approximately the same spread, or you compare the largest sample's standard deviation and the smallest, and the largest has to be less than twice the smallest. So I'm going to write it as large S over small s has to be less than or equal to 2. The calculations were the hard part in this unit. You probably noticed that. Lesson 13.1b was where we did the calculations. K is the number of groups, which that part's not hard, right? That's why I put a K up there. And capital N is the sum of all the small n's, or it's n1 plus n2 plus all the rest, all the way up to nk. X bar is the overall mean for all the samples put together, and I'll write it the long way first, because sometimes people get confused by that sigma thing. So it's n1 x1 bar plus n2 x2 bar plus, do the same thing for all of them, all the way up to nk x k bar divided by the big N. So all of the samples means multiplied by their sample sizes to get the total, add them all up, divide by the total of all the samples, or you could do the short version, which is ni xi bar over capital N. If you understand this, then you don't need to write this out. but writing this out helps people sometimes. dfs, there are 2 degrees of freedom for the numerator and the denominator. So for the good variation, it's k minus 1, number of groups minus 1. For the not so good variation, bad variation, it's capital N minus k, which is basically all the sample sizes minus 1 added together. And then this f, I'm going to write out the whole formula, although I don't think I'm going to make you do this on the quiz. It seems like that's kind of a mess. But it is MSG, that's the mean square for groups, over the mean square for errors. That's the good variation over the bad variation. These come from sums of squares divided by df1 and the sum of squared errors divided by df2. And then the long version of this sum of squares thing, this is the part that I don't think you'll need on the quiz, unless I change my mind, is you take your sample size, your sample mean for that group, minus the overall mean, squared and divided by df1, which is k minus 1. And then to calculate, this is basically measuring, the good variation is how far each mean is from the overall mean. That's the good variation. Bad variation is the standard deviations of each one squared times sample size minus 1, all over capital N minus k. So those are kind of complicated calculations, and I made you do them in the homework, but I think on the quiz I'm not going to make you do this. However, I might make you do some of this, like I might give you a partial computer table and make you fill in the rest, so you would need to know how to do this piece. P-value is FCDF. It's on the calculator in the same menu that you're used to using, and it's F999 DF1 and DF2, and this, in case you needed to remember, is in second bars. The same place we've been going through all the other CDFs. Or there's also a calculator shortcut where you put all your data in lists, list 1 through list k, whatever k is, number of groups, and then you go to stat tests and choose Anova and tell it which lists to look at. There is also a computer output thing. I'm thinking there's going to be one of these on the quiz where you have to use your calculator and not do this messiness, but do the calculator shortcut is what I have in mind. And then another one where you'll do computer output. And I'm going to put that information down below because I made a little chart for it. So I'll come back to that in a minute after I do the conclude. Conclude is the same as we've done in every other chapter, so I feel like we almost don't even need to write this. But if p is less than alpha, which, by the way, you should say what alpha is up at the top. I forgot to put that. Alpha equals whatever. You couldn't see what I wrote, but I just wrote alpha. If p is less than alpha, you reject. If p is greater than or equal to alpha, then you don't reject. I'm never going to make it equals because that's mean. Always include the justification, which is comparing p to alpha, the decision, which is reject or not, and the context, which is what is it we're rejecting or not rejecting. And I feel like we don't need the sample sentence because we've done it so many times before, but if you want to fit it in this space, maybe you're welcome to do that. So let's talk about the computer output and make sure you know where to find stuff. So the computer output looks like this for Anova, and it always has these same columns and same rows. It doesn't vary. This is sometimes called the group or the treatment or the factor. It is what usually ends up there is the name of your explanatory variable, which of course is a categorical variable in this chapter. A categorical variable with main categories. So it might be race, it might be gender, it might be something totally different. It might be which fertilizer did they put on the plant. DF and SS and MS, this is all the same stuff that was up there, but I'm going to write some of the formulas again just to remind you. So DF1 is k minus 1, and that number would be here. DF2 is n minus k. The computer output usually adds these together to get DF1 plus DF2, and that number is not super important for what we're doing right now. SS is the sum of the squares, which is the top of each MS formula. It's the piece with the sum of the squares in it. So this is called SST, and this is called SSE. We're not going to do a lot with these, although I will talk about them a little bit in the notes because there's something interesting about them that I want you to know. I'm going to tell you in the notes. MS, these are the good variation and the bad variation, so these are really important. MST is found by doing SSG divided by DF1, and MSE is found by doing SSE divided by DF2. This is the part that I might make you do, so I might give you a table that has this piece filled in and you have to find these, or I might give you these and make you find these and work backwards a little bit, just to see if you understand these formulas. F is found by doing MST over MSE, and P, of course, is the FCDF thing. Should do the same thing the calculator gives you. So I'm likely to give you a partial table and make you fill in the rest, or I might give you the whole table and make you just make a conclusion from it. So that's it for the chart. I will do a separate notes, that's the review notes, and they're also pretty short. So you have a choice of which one to do first, now that you've already seen this one.